Unit 11 is about bonding. So we will start with how to determine the type of bond you have. So electronegativity is a measure of the attraction an atom has for a shared pair of electrons. The fluorine atom has the highest electronegativity of every element on the periodic table, so it has the strongest ability to pull electrons to itself. So electronegativity values can be used to determine the degree of electron sharing. This demonstrates the type of bond that would occur. If you have a difference of 2.0 or more, you have an ionic bond. 0.1 to 1.9 is polar covalent, and the difference of 0 will be nonpolar covalent. So electronegativity values can be used to tell the degree of electron sharing, which demonstrates the type of bond. So between two elements, you'll be asked, are they going to form an ionic compound, a polar covalent compound, or a nonpolar covalent compound? And we can use this scale to figure that out. Here's an example. Water, which is H2O, between one hydrogen and one oxygen, there's a bond. What kind of bond is it? Hydrogen has an electronegativity of 2.1 and oxygen has a 3.5. So if we subtract these two values, and it doesn't matter which one you subtract from the other because we just want the absolute value, which is a positive number regardless. So the difference between 2.1 and 3.5 is 1.4. And 1.4 falls on the scale of polar covalent because it falls in here. And so water is a polar covalent bond. So the bond between the hydrogen and the oxygen right here is a polar covalent bond. It means that the electrons are being shared with each other, but unequally. They're pulling more closer to the oxygen than they are from the hydrogen. They're kind of pulled away from the hydrogen. So let's practice a few of these. You're going to need two things: a table with electronegativity values and the scale. Anything greater than 2.0 is going to be ionic. Anything that equals 0.0 is going to be nonpolar covalent. And that means that anything in between is going to be polar covalent. So 0.1 up to 1.9 is going to be polar covalent. So here I have KBr. K has an electronegativity of 0.8 minus, and then Br has an electronegativity value of 2.8. And when you subtract these, you're going to get 2.0. Remember, it's the absolute value, so we don't have negative answers. So since this is 2.0, that means that this compound is ionic. And so type of bond is ionic. The difference is 2.0. Okay, what if we have Br2? Well, that's bromine bonded to another bromine. So that's going to be 2.8 minus 2.8, which is going to give us 0.0, and that is going to equal nonpolar covalent. So this one will be nonpolar covalent. Next is Li2O, but we just care to do one of each. So I'm going to go find lithium, which is here. That's 1.0 minus oxygen, which is here. That's 3.5. So when I subtract these two values, I'm going to get 2.5. The absolute value, we don't have negative answers. So 2.5 is much greater than 2.0, which is going to make this ionic. So lithium oxide is an ionic compound. Our last example is going to be nitrogen NF3, nitrogen and fluorine. Just one of each. Nitrogen is 3.0 minus fluorine is 4.0. Does not matter that there are three of them. And then when we get the difference between these two numbers, we get 1.0, and you'll see that 1.0 falls in this middle range, which makes it polar covalent. And so the bond between a nitrogen and fluorine is a polar covalent bond. So to be more specific, what this really means is if you have an ionic compound, that means that the electrons get transferred from the metal to the nonmetal. If you have a nonpolar covalent bond, you have an equal sharing of electrons. If you have an ionic compound, again, the electrons are transferred. And polar covalent means there's an unequal sharing of electrons. And the electrons are generally pulled toward the more electronegative element. So in this case, because fluorine was more electronegative, the electrons are being pulled toward the fluorine and away from the nitrogen. Last topic is metallic bonding. Metals are made up of closely packed positively charged ions. The valence electrons surround these ions and can flow freely between them. This is often referred to as a sea of moving electrons, or a sea of electrons. The moving electrons attract the positively charged metal ions. This sea of electrons makes metals have the following properties. The reason we have this big sea of electrons is why metals are good conductors of heat and electricity. It is why metals are malleable, can be hammered into a flat sheet, or why they are ductile, which means they can be drawn into a wire. Alloys are a mixture of metals. Alloys have properties that are superior to that of the original elements. For example, brass is a combination or mixture of zinc and copper. Sterling silver is a mixture of silver and copper. Steel is a mixture of iron, carbon, boron, chromium, manganese, molybdenum, nickel, tungsten, and vanadium. And bronze is a mixture of copper and tin. So when you mix metals together to form an alloy, this is done because alloys are more durable, less malleable. They're not as easy for you to mold and shape, which is a good thing. You want them to be strong. And they're less likely to corrode. So let's take a look at this metallic bonding and alloy video. On the left side of this periodic table are metals. They only have 1, 2, or 3 valence electrons in their shell. They're going to tend to release these electrons, which allows them to be free to move around. And then the metals themselves turn into positive ions while they're surrounded by this sea of negative electrons. The electrons fill the spaces between the atoms, which give metals their properties. They are shiny. Electrons move fast and carry large amounts of kinetic energy, and so this is how heat and electricity can be conducted easily through metal.
Make metals good conductors of heat and electricity.
The electron blanket lets metals be worked into different forms. If electrons were in fixed positions, then you wouldn't be able to mold and shape the metals as well. Under a load, the ocean of electrons can move easily to allow for a rearrangement of the metal. To prevent them from moving easily, if you have a mixture of metals, such as alloys, then it's going to help the metal hold in place. So here you can add carbon to iron to produce steel, which could strengthen the metal. So now we'll focus on homework part 1 in your note packet.